Okay, in this video, we're going to talk about graphs of circular functions. In particular, these are graphs on a unit circle. A unit circle has a radius that's equal to 1. So if we graph a circle, that radius is equal to 1 all the way around. We have 4 coordinate points that are easily accessible. This one here is 1, 0. This one here is 0, 1. This one here is -1, 0. And this one here is 0, -1. Understand that all of these points that are on this unit circle are the cosine of the angle and the sine of the angle. So let's think about what happens to a point as we go around the circle. Here, the sine, which represents the vertical distance, our y-coordinate, starts at 0, goes up to 1, comes back to 0, goes to -1, and then comes back to 0. If we look at cosine, which is our horizontal distance is this way. It starts at 0, 1, goes up to 0, goes to -1, goes to 0, and then goes back to 1. So we can see as that we rotate this point all the way around the circle, the cosine values and the sine values are all going to oscillate between 0 and 1. We know from our triangles that we learned in the previous section that these values we can get from doing the cosine of theta and the sine of theta. And without going into a long thing about special right triangles and whatnot, just understand that we can do cosine of an angle, comma, the sine of an angle, and that will give us whatever point this is. But now let's look at what happens if we make a function of that angle. And instead of rotating it around, we create a function on a regular Cartesian coordinate graph. Let's look at sine first. Sine starts at 0, goes to 1, goes to 0, goes to -1, and goes back to 0. So it starts at 0, goes to 1, goes back to 0, goes down to -1, and then back to 0. We get what's called a sine wave. Now we can figure out what the lengths of these are using our special right triangles. I can say that the sine of 45 degrees is equal to √2/2, which is about 0.7. So if I come halfway in between here and here, this is going to be about 0.7. Now this graph is pretty crude, but if we look at what happens when I graph it on GeoGebra, we get this sine wave. It starts at 0, and then as we get to 45 degrees, which is going to be about 1 radian. 1 radian is 57 to -1, and then comes back to 0, and then goes back to 1. So if we want to look at what a cosine wave looks like, it starts at 1, goes to 0, goes to -1, which is about at 3.14159, about at pi right here, and then goes back to 0, and then it goes back to 1 at about 6.28, which is 2 pi. These are your basic sinusoidal functions for sine and cosine. Now you can graph these fairly easily. You can use a graphing calculator, or you can use GeoGebra, which I have here, and you can look at what you have here for what's going on with your sine waves.